amyloid plaques. So what are plaques? So plaques are mostly dense. They are insoluble deposits of proteins and cellular material outside and around the neurons. So these plaques, they are made up of beta amyloids. As I've said, plaques are insoluble deposits of proteins, cellular materials outside and around the neurons. So they are made up of beta amyloids. Because it's beta amyloid. So plaques, they are made up of this. They are made up of beta amyloids. And this beta amyloids, are formed from a larger protein. Don't forget I said that plaques, they are what? They are proteins. And they are made up of what? Beta amyloid. So they are insoluble proteins that are found around and outside the neuron. So these beta amyloids are formed from a larger protein in the cellular membrane. So what is the larger protein? It is called APP. But APP is what? You have the amyloid precursor protein. So APP is this amyloid precursor protein. Is the larger protein from which beta amyloid is being cut off from, and we have the proteolytic enzyme which adds for the production of this beta amyloids. The proteolytic enzyme responsible for the cut of beta amyloid into fragments. It's called, you have two basically. You have the alpha secretase, you have the beta secretase, and the gamma secretase. So these two cut beta amyloids into fragments, and the fragments are into we have beta 40, beta 41, beta 43, beta 45, beta 46, beta 49, and beta 50. So these are the fragments to which beta 51, brother. So these are the fragments to which the gamma and the beta secretase cut beta amyloid into. So let me give an expression. So we have the cell material. So we have the cell membrane. So here we have copy this. So yeah, say we have a cell membrane, we have a cell interior. So this is the APP molecule. It is directly attached to the cell membrane. So here we have a cut here. We have a cut here with the help of what? Beta secretase, and we have a gamma secretase. So these cleave off beta amyloid into fragments, making another representation of it. So as we can see, we have a gamma secretase enzyme. So cleaving at this point. So as you can see, this enzyme cleaves off beta amyloid from the larger molecule amyloid precursor protein in the neurons. So with that, I want to explain that. So let's talk about the case in Alzheimer's disease. So this is the metabolic pathway. Here, alpha secretase cleaves the soluble amyloid precursor protein directly from the amyloid domain. As you can see, the function of the alpha secretase, it cleaves this domain from the beta amyloid domain from the cellular membrane. And we have less of that here. We have less of it here. Also, moreover, the aid of beta secretase and gamma secretase cleaves directly the beta amyloid in the pathway by the action of amyloidogenic pathway with the help of what gamma secretase and beta secretase to form beta 41 and beta 40. So this enzyme makes use of presenilin. This is presenilin. This is it's a protein in the genes, the dominant gene in also beta secretase. The use of a protein called BRIS1. So as you can see, alpha synthetase, the cleaves at the beta amyloid point, taking out the soluble amyloid protein here, because you can see why gamma and synthetase make use of the cleaves beta amyloid and the amylogenic with the cleave with the help of amylogenic pathway. Alzheimer's disease, an apparent shift on the amylogenic pathway may occur, which may lead to an impaired clearance. So, in Alzheimer's disease condition, there may be an apparent shift which may occur, and it will lead to an impaired clearance, forming, giving out more of beta amyloid. Can you see? So when this is formed, there will be what? There will be more of amylogenic production. If there is what? A shift in an apparent shift in the production of beta amyloid. Don't forget I said what? That amylogenic pathway makes use of what? Gamma secretase and beta secretase for the production of what? Beta amyloid. So there may be an apparent shift leading to an impaired clearance, forming more of beta amyloid in the tissue. So it leads to what? The aggregation of what? Beta amyloid, making use of what? Copper and zinc. This one you can see, we have more of amylogenic beta amyloid into the cell, into the tissue. And this may lead to, it will induce oxidative stress, neuronal death, and there will be what? Fibrillation and beta-peptide sheath formation, amyloid plaques, inflammation, neuronal use. I'll come again. This is a diagram. In the metabolic pathway, they make use of alpha synthetase to form what? Which cleaves the soluble amyloid precursor from the cell membrane. As you can see here, we have less of it being formed here. A pathway called amylogenic pathway make use of what? A pathway called amylogenic pathway make use of gamma secretase and beta secretase for the production of what? Beta amyloid. And there will be an apparent shift in the production of beta amyloid, leading to what? The accumulation of what? Beta amyloid in the tissue. And when this happens, there will be progression, the production of what? More of beta amyloid being produced in the cell. As I said, I told you that right from the beginning, that when it comes to positive lesion, we have deposition or accumulation of what? Of deposits. We saw in the last previous video when we have more of what? Tau molecules forming strands together. Here we have accumulation of what? Beta amyloid in the tissue. And when this happens, it leads to oxidative stress, leading to neuronal death. At the same time, amyloid plaques. This affects, it causes inflammation into the brain. And these are the types of condition we have called Alzheimer's disease. So, from the beginning, we talked about, let's take this, a brief recap for what we talked about from the beginning. First time, from the beginning, we talked about Alzheimer's neurodegenerative disease, where we listed examples of them. We have the AD, we have the Huntington, we have the Parkinson, and the like. So we talk about Alzheimer's disease as a whole. We talk about Alzheimer's disease as a progressive neurodegenerative disease that affects the visual expression, that affects the memory, that affects the language, and some neurobehavioral activities of a person, of a patient that is affected by it. And we talk about the neuropathology of Alzheimer's disease, giving two examples basically, which are the positive lesions, I have the negative lesions. So under this positive, we have the amyloid plaques, we have neurofibrillary tangles, we have neurites, threads, and so on. Here we have the synaptic loss, we have the neutrophil loss. So positive lesion, they are called due to accumulation of deposits in the cell, probably in the tissue of the brain. Why this is done where the losses of atrophy, that is the greater loss of what tissue and muscles in the cells. And also we talk about amyloid plaques, and we give example, and we define microtubules, and at the same time the tau molecules that helps to stabilize microtubules. So we also discuss about the Alzheimer's condition. What happens when Alzheimer's disease occurs of a patient? So then we discuss that there will be, in a condition of Alzheimer's disease now, we will talk about LD neurons. Well, we have the microtubules, we have the tau molecules binding together to stabilize the microtubules. But in the case called Alzheimer's disease, the tau molecule, the tau protein, what happens? They form a cross-link, they are chemically discharged, chemically changed, they form a cross-link together. So their aid to stabilize the microtubules is distorted. There will not be what binding together of the microtubules again. So whereby causing a what distortion in the binding of the microtubules. And with that, it can lead to lack of communication in the neurons, and then also neuronal death. We also discussed about amyloid plaques, defining amyloid plaques as what dense insoluble protein deposits found outside and around the neurons in the brain. And we'll talk about beta amyloids, which are made up from what? Are made up of amyloid plaques, and they are formed from a larger protein called amyloid precursor protein, APP. And then we call two key enzymes, which are the beta secretase and the gamma secretase. These two enzymes are the key enzymes that aid to cleave beta amyloid from amyloid precursor protein. And we talk about how when there is an apparent shift in the production of beta amyloid, what happens? There will be aggregation, there will be accumulation of what? Beta amyloid right in the tissue, leading to problems. Also, there are more examples of conditions that can lead to neuropathology, because we also have oxidative stress can also cause it, pathology. We also have neuroinflammation, also cholinergic. So we have injury of cholinergic neurons. So these are the major pathologies that can lead to, you can see, disease progression or symptoms. So what happens? What happens that we see the symptoms of Alzheimer's disease? Positive lesions, we have the amyloid plaques, we have the neurofibrillary tangles, we have the neurolite traits, we have synaptic loss, we have neuronal loss, we have neurophil loss, we can have oxidative stress, we can have neuroinflammation, we can have injury of the neurons of cholinergic neurons. So these are examples of the neuropathology, the condition that can occur in the cell. Like I said, this is what happened that led to Alzheimer's disease. So thank you very much for watching this video. If you have any question, you can send directly down to the link video. Thank you very much.